Back when digital computing was first becoming a thing, think 1970s and 1980s, when there were still a lot of punch cards in circulation, and when terminals, which were basically access points for larger, room-sized computers, were still more common than anything you might call a personal computer, which were in some rare cases available from the early 1970s, but which were generally too expensive for individuals to own. Back in this early period of digital computing, commercially available software was limited, so the folks who used computers generally had to make their own software. If you wanted to use a computer, in other words, you had to learn to code, because otherwise that computer wouldn't do much beyond maybe turning on and off. Many people who had access to such hardware during these early digital decades were academics and scientists and researchers, professionals and students who had specific use cases for these devices, and they would thus build software optimized for their specific needs. So mathematicians might make programs that helped them perform complex formulas, and cartographers might cobble together code that helped them reproduce and share digital versions of maps. The first personal computers, where all the hardware was stored within a box small enough to fit on someone's desk, rather than filling up a room and requiring a desk-sized terminal just to access that larger processing hub, were usually called microcomputers and would typically be sold as kits. Many such kits could be ordered through hobbyist magazines and were generally limited in availability and would have to be put together by the end user. If you bought a microcomputer, you'd have to solder it into a working piece of hardware by yourself after you received all the parts in the mail. On top of that, you'd also have to acquire your own keyboard and monitor and disk drive and anything else you wanted to use along with the computational components. And those sorts of peripherals were also in short supply and generally required some amount of knowledge to find and use and integrate into a serviceable whole. Simply finding and acquiring and constructing a personal computer through the 70s and into the 80s then was an involved and somewhat specialized process. And though some early personal computers that we might recognize as such today were sold completely put together with their own monitors and disk drives and the like, became available beginning in the early 90s. That self-sufficient, we've got to build it ourselves mentality was pervasive in the computing space leading into the 1990s, when computer hardware and software began to enter a phase of commercialization. That commercialization was driven by entities like IBM and Microsoft, which were or became the behemoths of this industry for years, dominating hardware and software respectively, and suing the pants off anyone who infringed upon their portfolio of patents and copyrights. This led to a period in which many computer users and the people making the software for computers were ardent about the openness of what they were making. When they came of age as computer-savvy people, they were able to both see and edit the source code of all the software they used, which allowed them, in essence, to muck about with the genetics of that software. They could see how it worked, make it do other things, and even release their own spin-off versions of software someone else made. That's just how things worked by necessity. But as computers became more mainstream, and as there was more money to be made by selling hardware and software to business users in particular, that source code was increasingly locked down and considered to be intellectual property. Not only were you not allowed to see it, if you messed with it, changed it, even for personal use, and if you released your own software based on someone else's, there was a good chance you'd be taken to court. These companies wanted to protect their interests in this burgeoning industry. A counter-movement emerged in opposition to that shift toward intellectual property-related lockdowns, and there were many people and entities involved in this counter-movement, and quite a few variations on the general theme of wanting to keep things open and experimental and accessible. But one of the more successful concepts to emerge from this swirl of ideas is called open source, a concept that, again, was birthed in opposition to the growing mainstream movement toward locking down the source code of software, making it unseeable and unhackable by folks who might want to riff upon it or learn from it. Open source software today is delineated by a license that makes the software to which it applies free to use, study, change, and distribute, and that includes being able to open it up and see and tinker with the source code underpinning the software. There have been other similar movements, like the free software movement, that are similar in all but how they're applied and some specifics of the philosophy at the base of the label. But open source is arguably the most recognizable and successful of these movements, and part of its ubiquity and success is predicated on its relationship with the business world. As I mentioned, many of the people and businesses making computers and software for computers were keen to lock down their code and to protect it as intellectual property. But people making software under the open source license said, in essence, you business people, you can use this stuff too. And there might even be opportunities within this space to use open source software as foundational elements for businessy things. So you might want to build atop it, or even create businesses out of open source elements, as was the case with the Netscape Navigator browser, which was open source and served as the foundation of the original Netscape business, and later for Firefox and several other modern web browsers and the businesses or associations behind them. What I'd like to talk about today is an open source project that has become fundamental to a huge chunk of the internet, and what happened when a serious vulnerability was discovered in that project. You're listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent, listener-supported show. If you're enjoying what I'm doing here, consider becoming a supporter. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. You can also become a member at understandery.com. But you can find an array of options, both monetary and non-monetary, at letsknowthings.com/support. A great big thanks to everybody who's already helping to support this show, and thank you in advance if you're considering doing so in the future. All right, let's get back to the show. Apache is a non-profit based in the United States, which manages and supports scores of current, past, and incubating potential future open-source software projects. Key among them, the Apache HTTP server, which is one of just a few commonly used web-based server platforms that emerged in the mid-1990s as the everyday person-accessible internet was just blooming, and the World Wide Web, a visual, hyperlinked together interface for accessing many of the things that were being built for the wider internet via a page system, was beginning to look like it could actually happen, and might someday even attract a fair number of users. Apache became the largest HTTP server by the end of the 90s, and by 2009, it was the first such software to be used on more than 100 million websites. For clarity, HTTP, or Hypertext Transfer Protocol, is the protocol that allows stuff on one computer to be delivered through the web to display on other computers. The websites you visit are stored on some remote computer, these days typically physically located in some kind of data center, with racks and racks of servers, which are computers optimized to serve information to other computers in this way. And an HTTP server, like Apache, basically allows this protocol to function, arranging data on the serving computer in such a way that the bits and pieces in between know how to deliver it, and what to put where, and what everything should look like. It's a lot more complicated than that, of course, but fundamentally, this software is what allows the web, and thus all the pages on what we colloquially call the internet, but is actually the World Wide Web, to function. And Apache is used, according to some recent figures, on nearly a quarter of the busiest and most popular websites on the internet as of 2021. It's the most commonly used option in this space. So the Apache HTTP server software is immensely popular, widely used, and open source. So it's managed by this larger entity that also manages a slew of other open source projects. But it can be used and viewed and messed around with by anyone, and it's maintained and upgraded by thousands of coders who make the software, often unpaid, though on occasion paid by a business that uses Apache and thus benefits from its continued success and security. But this is basically just a scaled up version of what we see across the open source ecosystem. The same general rules apply, which makes it fairly flexible in that many people are working to keep it chugging along and working well, no matter how the tech environment around it might evolve. But this popularity also makes it a tempting target because of how widely used it is, including by many of the largest companies and organizations in the world, and because people can see the source code, which can give them insight into how they might attack it. Log4j is a logging framework that is maintained by Apache, so it's likewise edited and upgraded by folks working for free, or in some cases paid by their employers to sometimes commit the work they do for the company back to the larger open source project. And a logging framework is a fundamental utility that works in the background when you use software, and it basically just keeps a log of what the software does, which is super helpful if you're one of the developers tasked with figuring out what's happening within a given piece of software or application or website that's behaving strangely, without having to do anything that makes folks on the other end, viewers of a website or users of an app, aware that you're testing things. You can check the logs, make some changes, check the logs again, and that will probably tell you what's happening behind the scenes in a private but useful fashion. There are other logging utilities available for use with Apache servers, but Log4j was developed early on to fill a hole in early Apache server releases, and consequently became the baseline default for a lot of developers and projects. It can be a pain to change to a different way of doing things after doing them one way for so long. That utility is baked into all the code you're making, so Log4j continued to be used and continued to be integrated into newer and newer projects because folks became accustomed to how it operated, and because other software tools they were using were reliant upon it. It became a brick in the foundation of the web. And that brings us to the article I'd like to unspool today. It comes from Gizmodo, and it's entitled, Log4j Vulnerabilities Are Piling Up as Companies Scramble to Patch. On December 9th, 2021, a zero-day vulnerability, which means a weakness that the people in charge of securing and maintaining a piece of software don't know about, was published by the team managing security at Alibaba Cloud. Alibaba being a massive tech company which provides cloud services, among other things, in China. They released this information to make the larger tech world aware of it, and in doing so, named the vulnerability Log4Shell. The vulnerability they'd noticed allows anyone who takes advantage of it to launch what's called arbitrary code execution in the now exposed system, which is a very serious issue because arbitrary code execution is a fancy way of saying the attacker can run any code they want within this system they've broken into. And that means they stand a pretty good chance of stealing, breaking, vandalizing, destroying, or otherwise messing with anything they want within the data storage system, website, application, or whatever else they managed to access. The degree to which this is an issue cannot be overstated. As I mentioned before, Log4j is used in tandem with many server setups because it's been essentially built in to many other tools and is familiar to many of the people who use these platforms to do what they do. That a hacker can relatively easily break into any system via a flaw in this tool and run any code they want, handing them the keys to the digital kingdom, essentially, is a 5-alarm fire. Or said another way, according to the Apache security team, this was a 10 out of 10 on their vulnerability severity scale. Other folks who work in cybersecurity have called this a, quote, design failure of catastrophic proportions, end quote, and, quote, the single biggest, most critical vulnerability ever, end quote, and have said that the consequences of this vulnerability, quote, border on the apocalyptic, end quote. So yeah, it's less than ideal. Some points that I think are worth making here. First, unless you work in some aspect of cybersecurity, it's unlikely you can personally do anything about this. Most of us won't need to update anything or be more careful with our passwords. This is a large-scale foundational issue, and the entities that are able to do something about it mostly are, to the degree that they're able, right now at least. Some institutions might have more trouble than others because they'll have to work through all of their systems, all of their code, to make sure this tool is either fully patched or completely removed. And that can take time when you're working on the scale of millions or tens of millions of lines of code and a whole lot of systemic, casual reliance on software utilities built by others. Second, as I just alluded, there is a patch, and it became available very shortly after this vulnerability was noted by the Alibaba team. So the open source community did a good job at sealing this weak spot up quickly. Now the race is to deploy that patch, that software update, to as many entities as possible, as rapidly as possible. And many of them have already done so, and it'll likely just be the more software cumbersome organizations we'll need to worry about in the coming months. Third, I know I just said it's only a relatively small portion of impacted companies and organizations we'll need to worry about moving forward, because they will be particularly slow to roll out that patch, but it's generally assumed a lot of damage has already been done, and now it's a matter of working through what hackers have managed to steal and break, and figure out whether they've left back doors before leaving, which might allow them to continue accessing these systems even long after the Log4j related holes are patched up. This is part of why folks in the cybersecurity world are telling us to expect months of announcements related to incursions and data that's been stolen and stuff that's been broken. There are just a lot of malicious things that can be done in a relatively short period of time with the kind of control that this vulnerability granted these entities, and some hackers seem to have made good use of that time. There's a good chance, in other words, that we won't hear about some of the worst and most damaging things that have already been done and that are being done today for months or years. Fourth, some of the hackers who used Log4Shell right after it was announced, and reportedly before then as well, were individuals or small groups, using it to do the same sorts of data stealing, ransomware installing things they were already doing. This was just a simpler means of engaging in the same sort of criminal activity. There's evidence, though, that some groups, including some higher tier groups tied to governments, may have utilized this vulnerability to attack typically hardened targets, like government data stores and software. which is something that's happening to various degrees all the time. But there's a good chance, based on some reports, that some of these targets were quickly breached during this moment of enhanced hacker capability, which could have some large-scale repercussions down the line, including heightened tensions and/or conflict between these governments. And fifth, this could spark a sea change in the way cybersecurity is conducted and thought about by folks looking to secure systems that are connected to the internet. In essence, this shows us we've been long vulnerable to this type of risk, and any one of the countless tools we casually use, combining hundreds or thousands of individual projects into new projects, building atop them, and in turn, creating new weak spots. They could all, any one of them or many of them, likewise put us at risk in this way. And because of the scope and scale of what's been built, the only way to really know that this is the case is to notice when you're attacked, and to then try to trace that attack backward to the vector through which it was launched. What we're doing then, both in terms of how we build these tools and in terms of how we protect the things to which they're connected, may not be viable for much longer. Not if we want anything connected to the internet to be secure, at least. Something else that's being discussed in the wake of this unfortunate situation is that this tool was built by one person and is maintained by a small number of unpaid developers. And that is despite the fact that it is used for free by so many entities around the world. Entities like Google and Facebook and Amazon and Apple and Alibaba and governments. These are not cash-strapped startups or individual users. They're some of the wealthiest entities on the planet, some of which do provide small grants or similar bundles of cash to the organizations maintaining such software, like Apache, or to individual coders who contribute to them. But those grants almost always are nothing like the money being thrown at other things, being thrown at other tools and projects, which these companies exclusively control and protect. Someone trying to make a living from open source coding will typically be lucky to make a tenth of what a coder of equal skill would make at one of the companies that uses their open source software for free. And this is a well-known disparity within the tech world. But it's something that may garner additional attention now that these weak spots are being noticed, and the potential benefits, perhaps even necessity, of investing more generally in open source software and the people who maintain and build such software are so glaringly obvious. It's impossible to know whether this issue would have been discovered and patched before it was exploited, had there been better paid or paid at all coders keeping it updated and fully functional. But the possibility that future exploits of this kind might be fixed before they're discovered and utilized by malicious actors would seem to justify such investments. If you're enjoying Let's Know Things, consider becoming a supporter. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. You can also support this and my other projects by becoming a member at understandary.com. But you can find a full list of both monetary and non-monetary support options at letsknowthings.com/support. A great big thanks to everybody who's already helping to support this show, and thank you in advance if you're considering doing so in the future. The book I'd like to recommend today is called Rationality: What It Is, Why It Seems Scarce, Why It Matters, by Steven Pinker. Pinker is one of those authors who's made a name for himself by presenting complex topics in an almost TED Talk-like way, which is to say they become very accessible and interesting and inspiring, but they're also sometimes simplified, and a lot of the stories presented in his work are just so stories. They're stories that are a little too neat and tidy, which make the point he wants to make very effectively, but aren't necessarily fully supported by all of the data available, or by looking at the world from any other point of view than that of a well-studied, well-respected, well-published academic. Now, all of that said, I tend to enjoy his books because I do tend to find them informative, but also inspiring because of what some of this data says about humanity and our potential. And I tend to believe in humanity, despite many reasons that we might have for not believing in humanity. This book is exactly that. It's an argument for why humans are not these thoughtless cavemen who are slaves to our emotions, but instead have this array of tools that we've developed and that to some degree come naturally to us, that allow us to make better decisions and that allow us to solve new problems as they emerge. Now, if any of that sounds interesting to you, consider picking up a copy of Rationality by Steven Pinker. You can find out more about me and my work at Colin.io. You can find the show notes and transcript of this episode and every episode of the podcast at letsknowthings.com. You can find a portfolio of my other projects, both written and audio, at understandery.com. And feel free to reach out and say howdy on social media. I'm Colin Wright on Facebook and at Colin is my name on Twitter and Instagram and most of the other ones. Thank you so very much for listening. I'm Colin Wright, and I'll talk to you again next week.